Now, there's certain things that we could talk about trigonometric functions and their properties, and we could talk about how they're even or odd. And remember, even is symmetric with respect to the y-axis, and odd is symmetric with respect to the origin. We could say give it a period. So for a period, in our case for trigonometric functions, this is how long until it repeats. And we'll talk about that in a minute. And then we could talk about, we know if even or odd, remember that's f of negative x equals f of x if it's even, or equals negative f of x if it's odd. So we think about the unit circle, right? And we have revolutions, right? And we go around once, and then once we get here, we've gone 360 degrees, what happens? It starts repeating again. So all the values are the same. Remember, we have a terminal side and go around and see where we land. If I land here, how many times do I go around? Every time I go around, I'm hitting here. And it's going to be the same values for my cosine and sine for this terminal side, regardless of how many times I go around. So a period, I said, a revolution is 360, but we like to talk about in radians. So a period typically is 2 pi for my sine and my cosine. But think about tangent. Tangent is sine over cosine. And since sine and cosine repeat, and remember, tangent is positive here and here, it turns out that by the time I get down to the third quadrant, I'm repeating again. So tangent has a period of pi, because after pi, it repeats again. And when we get to graphing, we'll see much better how that happens. But here, sine and cosine are both the same sign. They're negative, and tangent is positive, and so the values are the same, because it's always the ratio from sine to cosine. So remember, and then if we have periods that are of sine, cosine, and tangent, then the periods are the same for their inverse functions. So let's just look. And for my trig functions, for sine, I have a period of 2 pi. And it is an odd function because I know that sine of, we could say sine of pi over 3 is negative the sine of negative pi over 3. Because you think about it, sine is positive here and negative here. This is pi over 3, this is negative pi over 3, so they're negative of each other. Cosine, on the other hand, also has a period of 2 pi, but it is even. Because cosine of pi over 3 equals cosine of negative pi over 3. Because there is positive in both these quadrants. Tangent has a period of pi, and it also is odd. Because tangent in this quadrant is the negative of the tangent in that quadrant. Okay, then secant, probably says a cosecant. Cosecant, which is the inverse of sine, also has a period of 2 pi, so it also is odd. Secant has a period of 2 pi, it's the inverse of cosine, so that is even. And cotangent has a period of pi, and it also is odd.